So I got this shiny Ponyta in Legends Arceus, and it got me thinking, what makes anything shiny? Yeah, that's my intro. Is that okay? Oh yeah, it's my video.
We know we can see things because of electrons moving up and down their positions in an atom. What does that mean? We excite the outermost electron with a photon.
In addition to an electron's energy level, the electron's position is also important to how the overall material behaves.
And that has something to do with why some metals have colors and some are just silver.
I explained that in my next video, and as usual, thanks for watching. I'll see you next time.
At first glance, molecular cages sound pretty intense, even though separately we know them well. Molecules what make up stuff, and cages, things we make to put children in, I don't know. It's probably the idea that a cage can be made in such a tiny scale that makes it sound so mysterious. Like, how do you even assemble a cage at that tiny scale in the first place?
Everything in this video is just based on a simple fact you've probably known your entire lives. Like charges repel and opposites attract.
But that we can creatively apply that to make complex systems like molecular cages even more efficient is so goddamn cool. I hope you enjoyed this video. Thanks for watching. I'll see you next time. If you cut your body into its constituent parts and add their masses together, this is of course the same as getting the mass of your body as a whole. For particles, it's not quite the same. Now, majority of the mass of particles around us comes from protons and neutrons. Electrons make up a tiny bit, so we can ignore them. Now, these protons and neutrons are made up of smaller things called quarks. Where did all the other mass come from? Mass, especially in this context, isn't really the amount of stuff something has.
We don't need to get too existential about it, and that's just how science works.
Now, if your context is you're someone who wants to understand how stuff works at the tiniest of tiniest scales possible, then I hope this video is able to help you do that. Thanks for watching. I'll see you next time. Particles have wave-like properties.
This statement, one of the main ideas in tiny physics, can also explain why the sun, huge as it is, can make all kinds of elements, all kinds of energy that we rely on.
Gravity alone isn't actually strong enough to merge atoms together, but nature has something else that allows gravity to do that.
You guessed it, it's quantum tunneling. We'll start by setting up a graph. So there's a lot of stuff I explained, from what an energy barrier means in the context of the sun, to using the total energy of the system to show you how quantum tunneling is possible, but really the main thing I want you to take from all this is how amazing ideas in the quantum scale are, and that they can explain how the sun does its sun things.
Particles have wave-like properties. That's it. As usual, do subscribe if you want more science and what I think are cool animations. While you're here, do check out my gravity and dark matter videos. Thanks for watching. I'll see you next time. Dark matter. Called dark matter because we can't easily use electromagnetic radiation to detect them, as we normally do with other objects. Doesn't really sound like the end of the world to me. I mean, neutrons, protons, and electrons are things we can't see, but we know they exist. Years ago, the electron was just another weird particle we didn't understand, but now its ability to move around is the reason you're watching this video. Imagine what we could do with dark matter. A super exciting possibility is a 100% efficient source of energy. Watch this next video and you'll see why. Once again, thanks for watching. I'll see you next time. So, knowing how much space-time curves allows us to identify how space is structured. We can see regions in space that appear distorted due to gravitational lensing, which is when an object appears different from the way it actually looks. Because light coming from that object runs through a path that isn't exactly straight, thanks to the massive object warping space-time in between us. Explosion of energy, quantified by the also beloved E equals mc squared.
This tells us that a gram of matter and antimatter would produce the energy equivalent to a nuclear bomb exploding.
So far, combining all the antimatter for normal matter we've ever produced, less than a microgram thanks to these expensive facilities, would not even be enough to heat up tea. Now, how's any matter capable of being its own antimatter? Oppositely charged to its counterpart matter. Gravity, the reason rain pours downwards and apples fall down trees. But it's also the reason for one of the most tragic ways you can die in a video game. So what? Well, it's not all about things falling down. It's because of gravity that clocks on Jupiter tick slower than clocks on Earth. That there are regions in space where nothing, not even light, can escape it. And that some things aren't where we think they are. We all learn in unique ways, and when there are more science communicators out there teaching in those unique ways, we increase our chances of engaging more and more people in science. Your job is to promote that activity to around 5 people you know. And when there's a good number of us doing that, we all made the world a little smarter than it was yesterday.